Welcome to Hobby Electro Lab. In this video, we'll be building a DIY fire alarm circuit using simple electronic components. This project is perfect for beginners interested in electronics and PCB design. Follow along as we explain each step and component in detail. Let's get started. In this project, we'll build a fire alarm circuit that triggers a buzzer and LED when high temperatures are detected. Key components include a 741 op-amp as a comparator, an NTC Thermistor for temperature sensing, and a transistor to activate the buzzer and LED. A PCB layout will ensure a compact and durable design. By following our video, you can easily assemble the entire circuit step by step. The most important part of this project is calibrating the circuit to trigger the alarm at the correct temperature. This ensures the alarm activates precisely when the temperature reaches the desired heat level. After placing all the components onto the PCB, trim any excess leads for a neat finish. Then, carefully solder each connection to ensure a strong and reliable bond. To calibrate the circuit, you can use a heat source like a hairdryer. However, a match flame or hot soldering iron will also work if used carefully. Keep these heat sources at a safe distance from the thermistor to avoid damage. In this circuit, the op-amp functions as a comparator, detecting voltage changes from an NTC thermistor, which lowers its resistance with rising temperature. A variable resistor sets the temperature threshold. When this threshold is met, the transistor switches on, activating the buzzer for an audible alert and LED for visual indication. The 100K NTC thermistor detects temperature by decreasing its resistance as heat rises. In this project, it acts as the temperature sensor that triggers the alarm at a set threshold. This fire alarm project is also available as a PDF file. If you'd like to receive the PDF, simply ask in the comment section, and I'll provide the download link in response to your comment. Once all components are fixed onto the PCB, insert the LM741 operational amplifier IC into its socket as the final step. Now it's time to test and calibrate the circuit. Set the power supply to 9V DC and connect it to the circuit to begin calibration. When fixing the thermistor, place it in open air for accurate temperature sensing. To calibrate the circuit, set the variable resistor to its mid-range to adjust the alarm trigger threshold. Right now, the circuit is at room temperature. If you hold the thermistor between your fingers, your body heat will warm it up, causing the buzzer to sound. Cool down the NTC thermistor with a cold object to stop the buzzer. To set the buzzer to trigger at a higher temperature, you can use a match flame or hot soldering iron for calibration. Hold the match about 5 to 10 centimeters away from the thermistor. Start at a safe distance and bring it closer gradually to avoid overheating and damaging the thermistor. To calibrate with a hot soldering iron, hold it near the thermistor, about 1 to 2 centimeters away, but not directly on it. Watch for the circuit to respond as the thermistor heats up, and move the iron slightly closer if it doesn't trigger at your desired temperature level. This fire alarm project is also available as a PDF file. If you'd like to receive the PDF, simply ask in the comment section, and I'll provide the download link in response to your comment.